All right, in the next set of notes, we're going to talk about energy of motion. Now, this is a topic that we have covered a little bit already. You may remember in the homework that was assigned about Wally the astronaut stranded in space, trying to find his way home using a fire extinguisher, we talked about calculating the amount of kinetic energy that Wally had. So we know that when an object is in motion, it has kinetic energy, and there is a formula for that that allows us to calculate how much kinetic energy that object has. K here, you may remember, is the symbol that we use for kinetic energy. Kinetic energy is measured in joules, just like work is, Joules. We use an uppercase J for joules. M here is the mass of the object. Remember that the mass of objects in physics is always measured in kilograms. And V here is going to be the speed of the object measured in meters per second, the speed of how fast that object is moving. Something to remember about this formula is that only the V term is squared, not the 1/2 or the M. So let's just do a couple practice problems with this. The first one over here on the right, we've got asteroids that are constantly bombarding the Earth and often explode as they heat up when passing through the atmosphere. I've given you the mass of an asteroid, and I've also given you the speed of an asteroid when it hits Earth atmosphere. And I would like for you to please calculate the amount of kinetic energy that that asteroid has. Go ahead and pause the video right here. Do the calculation, see what number you get, and we'll check answers in just a second. So hit pause, try it on your own. Okay, so kinetic energy is given by 1/2 mv squared, and we're just going to plug in what we know. We have a mass of an object of 5 × 10⁶ kilograms. We have a speed of 10 to the 4th meters per second, and we're going to square that value. Put those numbers in your calculator here. We get a kinetic energy of 2.5 × 10 to the 14 joules. That is a ton of kinetic energy. Energy is kind of a weird unit being measured in joules. It's not one that we're mostly familiar with. If you think about a 1-ton explosion of TNT, which is a pretty common explosive that's used in demolition, a 1-ton TNT explosion is going to create a huge flashbang. It's going to create a hole in the ground that is 10 meters wide, a massive explosion of heat and light and sound, and then a shock wave, pressure wave that's going to expand outward. That amount of kinetic energy released in a TNT explosion is going to be about 10 to the 12th joules. And if you remember anything about the way the scientific notation works, 10 to the 14th is 100 times larger than 10 to the 12th, meaning that this asteroid coming in is 100 times more energetic than that TNT explosion. You can think a little bit about why asteroids are so destructive when they actually collide with planet Earth. Now let's look at the example on the bottom here where we have a soccer ball. It's moving, a goalie kicks it in the opposite direction, and we want to actually calculate now the change in kinetic energy of the soccer ball. Thinking back to what we know about calculating change, we use the Greek letter delta for change, the symbol delta, symbol K for kinetic energy, and change is always calculated as the final minus the initial value. So we want to be able to calculate the initial kinetic energy of the soccer ball and then the final kinetic energy of the soccer ball, and we're just going to take the difference between the two. So again, hit pause, calculate the initial, calculate the final, take the difference, and we'll compare our answers. All right, I'm going to calculate the initial kinetic energy of the ball, 1/2 times the mass, 0.45 kilograms, times an initial velocity of 0.8 meters per second. Square that whole thing. We get an initial kinetic energy of 1.44 joules. Calculating the final kinetic energy here, 1/2 times 0.45 kilograms times a velocity of negative 3.5 meters per second. Ooh, why did I make that negative? Think about what's happening. We hit this ball, it moved to the right, the goalie kicked it, and it moved in the opposite direction. So we do have to make sure that the signs of our values are correct. Now, maybe you can think ahead though. If you square a negative, you're going to get a positive number. So either way, you should get positive 2.76 joules. You will never have a negative kinetic energy. Make yourself a note of that. No negative kinetic energy. So to calculate the change, we do final minus initial. So 2.76 joules minus 0.144 joules gives us a change in kinetic energy of 2.61 joules. Let's think about what that means. That is an increase in energy Remind me, why do we have an increase in energy? What has to happen for something to experience an increase in energy? It's because we have positive work that's been done. What did the positive work? The goalie kicking the soccer ball.